Okay, we're just going to look at a few examples from some of the problems from Chapter 3 or from Section 3-4 that I have not done yet. So let's take a look at number 6. I don't think that was assigned for homework. Speeding bullet. This, by the way, is on page 130. So a bullet fired straight up from the moon's surface would reach a height of S equals 832t minus 2.6 t squared. So this is the moon. After t seconds. On Earth, in the absence of air, its height would be S equals 832t minus 16 t squared. So this is on the Earth. After t seconds. How long would it take the bullet to get back down in each case? So we are looking at when it's going to land, the amount of time it would take for it to land. Okay, so for this problem, we've got some pretty simple algebra for this one, so let's look at the moon. Since we want to know how long it would take for it to get back down in each case, we want to know when is the position 0. So that's really all the question's asking. So for the moon, we have 832t minus 2.6 t squared equals 0. I'm going to factor out a t. So we get t equals 0 and t equals, set this equal to 0 and then solve that. You're going to get negative 832 over negative 2.6, which I did on my calculator over here. And we get 320, and my time is in seconds. So as far as on the moon, it would take 320 seconds to get back down. That's all the question was asking. So sometimes you're just doing some simple algebra problems, but the hard part is being able to read the question and recognizing that this is what it was asking for. All right, let's take a look at number 9. Draining a tank. The number of gallons of water in a tank t minutes after the tank has started to drain is Q of t equals 200 times 30 minus t, quantity squared, t is in minutes. Okay, how fast, and this was gallons of water, how fast is the water running out at the end of 10 minutes? So we want the rate of change at the end of 10 minutes. Well, remember, when you're talking about how fast is it changing or what's the rate of change, we're looking at the derivative. So I need to know what q prime of t is. That tells me my rate of change. So to do this, I'm going to employ the, I'm just going to use the power rule with the chain rule here where it's going to be involved. So we're going to get 400, 30 minus t to the first power when you decrease that, times the derivative of what's inside. And the derivative of this is negative 1. So I get negative 400 times 30 minus t. And the question was, at the end of 10 minutes, how fast is the water running out? So I need to know q prime of 10. So I'm going to plug a 10 in there. So I get negative 8,000. And my units. So we were talking about gallons. So it's gallons per minute. Now, the negative tells me that it is that the water's flowing out. So it's flowing out at a rate of 8,000 gallons per minute. Okay, so that's like an instantaneous at exactly 10 minutes. But that's different from the next part of the question that they asked. What is the average rate at which the water flows out during the first 10 minutes? So now I'm being asked about the average rate over that 10-minute period. So then I'm going to be looking at Q of 10 minus Q of 0 over 10 minus 0. That gives me the average. So remember, instantaneous rate is the derivative. Average rate is just like finding the slope. So I'm going to plug in a 10 into my function. I'm going to do that separately and then come back here. Okay, so when I plugged in a 10, I got 80,000. And when I plugged in a 0, I got 180,000 over 10. So I get negative 10,000 gallons per minute. So it's average, let me look at the question again, the average rate at which the water flows out during the first 10 minutes would be it's flowing out. So it flows out at a rate of 10,000 gallons per minute. So if I, depending on how I'm going to say that, if I say it's flowing out as part of my reporting my answer, then I drop the negative because it's flowing out. So that would be how, that's the average rate of change. Okay, let me show you, and this is on one of the homework problems. And in part B, they ask you to graph the numerical derivative of, and then they have three functions. So one of them, I'll just do this first one, g of x equals x cubed, which you already know the derivative is 3x squared, so you know what that should look like. But let me show you how to graph a numerical derivative. So here, what I'm going to do is I want inderiv, so I'm going to go alpha f2 and go down to inderiv. So I'm going to, with respect to x, plug in x cubed. Now remember, inderiv returns a particular value, so it would evaluate a derivative for a particular point. But if you want to graph for all x, then you just put an x here instead. And that should graph it. So I'm going to go zoom 6 for a standard viewing window. And I end up with this graph, which is, because we already know g prime of x is 3x squared. So that shouldn't surprise us when we see that we get a parabola. Not a big deal here, but you'll find that graphing inderiv can be extremely helpful when you have a really messy function. So say I had some weird function, f of x, or let's even do this, because we're going to be dealing with the derivatives of sine and cosine next. So let's graph the derivative of sine x and see if we recognize that. So I'm going to go y equals, and Ryan, when you do this, you're going to hit math num, I believe it's under. Oops, maybe not. Math. Oh, I went past it, didn't I? It's right under math, inderiv. When you select inderiv, you're going to have to type in the function, comma, x, because x is your variable, comma, your starting value is, I think you have to have 3 x's. I'm not sure if this, because this is going to give me the pretty one. So I might have to show you later. All right, so we're going to do with respect to x. And let's put in sine x. And put in an x here. And one other thing I need to definitely make sure I've done is, I think I need another parenthesis. Okay, so let's make sure that your calculator is in radians, so double check that. And now I'm going to go zoom, and I'm going to do zoom 7 for trig. And this is the graph. Now, what it's graphing right now is the derivative of sine. So take a look at that function. That should look familiar. Remember, sine goes through 0, 0. This one looks a lot like it, but not quite. So this should look familiar to you. So hopefully you're thinking it right now. F prime of x equals cosine x. And that's one of the things we're going to be doing coming up in the next section. Okay, Ryan, I just looked it up for you. You're going to do inderiv, and then in parentheses you'll have your expression. So you would have x cubed, which I know you have to do with the little caret button. And then you'd put your variable, and then you would put the value, but in this case we want it to graph for all x. So this is what you would put in y1, and you should get the graph. That would be for this one up here. You would just put in, for this one, you'd put in a sine x, comma, and then that should graph, so you can try that.